Continuing with topic 3, paper 12, we're asked the question, what is risk? The top of page 3.6. Now, risk with regard to investment is the uncertainty around investment returns. That is, how are investment returns going to vary from the expected return? Now, if you get exactly what you expect, there is no risk. But with many investments, that's not the case. You may get more than you expected, but you may also get less. And that's the second point there. It says for an individual, risk usually refers to the possibility of incurring a loss. But in finance, risk refers to both downside and upside potential. Now, we measure risk of an investment asset by standard deviation. Now, how do we calculate standard deviation? Well, first of all, we've got to calculate the expected return of an investment. And that will be a function of returns that we are forecasting and the probability of those returns occurring. And we get the fancy formula, although it's very simple, in the middle of page 3.6. Let's look at an example. Dead Certainty Limited has the following return probabilities for the next year, and we're asked to calculate the expected return. And the probability of a 4% return is 30%, probability of an 8% is 50%, the probability of a 10% return is 20%. Now, this is just a weighted average calculation. You multiply probability by the return. And in actual fact, you don't take percent multiplied by percent. It would be 0.3, the decimal, multiplied by 4% gives us 1.2. The same for the other two returns, applying the probability, and we get an expected return, a weighted average of 7.2%. So given the data that we're presented with, we're saying the expected return is 7.2%. Now, moving on, we're now going to look at the measure of risk. And this can be measured by variance and standard deviation. Well, one comes from the other. Standard deviation, which is the standard measure of risk, is the square root of the variance. And there is the formula. Do I need to know this for the exam? Unfortunately, yes. You may get a question asking you to calculate the standard deviation. If you did, it would only be one question. Now, it looks fairly daunting. What it is we add up the differences between each forecast return and the expected return multiplied by the probability. And because in some cases, the forecast return will be less than the expected return, you could have a negative value. Well, if you added those all together, they're just going to cancel each other out and you get zero. That is why we square the difference, add up the differences with the probability multiplied, and then we take the square root. So we're squaring to get rid of the negatives, and then we're taking the square root to get back to the measurement value. So let's look at an example. Dead Certainty Limited and Good Chance Limited, so we've got two companies, have the following return probabilities for the coming year. Whereas calculate for each stock the expected return, variance and standard deviation. Well, we've already done the expected return for Dead Certainty, and that appears again at the top of page 3.8. We've applied the probabilities to the returns, multiplied across, added up, in the middle number there, 7.2%. Now, to get to the variance and therefore the standard deviation, for each, we take the difference between the forecast return, so the first line is 4%, so that's 0.04, and we would deduct from that the expected value, 7.2% in decimal. Then we would square that value and multiply by the probability of 0.3. Now, unfortunately, we have to keep all those zeros in, so we get 0.0003072. Now, you follow the same format, perform the same calculation for the return of 8%, the return of 10%, and we get the three values on the right. We add them up, and that is the variance, 0.000496. Now, the variance, yes, is a measure of risk, but it's not as meaningful as the standard deviation when we take the square root. So we take the square root of 0.000496 and we get 0.0223. Now remember, we've been dealing in decimal, so we can translate that back into percentage, 2.23%. The measurement used for the standard deviation is the same as the measurement used for the returns. The variance would be different because it's a squared value. So we always go back to the standard deviation, 2.23%. Now, how would we interpret that? We would say that the expected return of dead certainty is 7.2%. with a standard deviation, with a measure of risk of 2.23%. Now, on its own, that's fairly meaningless. It makes more sense when we compare it to another investment. So let's look at good chance. 3 probabilities, different returns this time, 2, 10, and 20. And you can tell immediately that the returns are more widely spread than dead certainty. The expected value we calculate in the same manner as dead certainty, and we get an expected return of 8.8%. So we see that good chances expected return is greater than that of dead certainty. So we're investing, surely we want the higher return. But let's calculate the standard deviation. Using the same process, we take the difference between the forecast returns, the expected return, we square the difference and apply the probability. For the 3 forecast returns, we add up those values and we get a variance of 0.004416. Now that's the variance. Again, we have to take the square root to get the standard deviation. We follow the same process and we get a standard deviation of 6.65%. So while good chance gives us a higher return than dead certainty, we also have higher risk in that the standard deviation, the variation measured in percentage around that expected return is greater, is 6.65. So our conclusion at the bottom of page 3.8 is that good chance compared to dead certainty, it has a higher expected return, but at a higher risk. That material could easily be subject of a question at paper 12. Let's now look at the normal distribution curve. And again, this is likely to be addressed in the exam. What is the normal distribution? Well, illustrates, I should say, dispersion of a securities return around the expected return. It's a bell-shaped curve. We have the expected return in the middle, and we see the different forecast returns on the left and on the right. Now, security X is closely clustered around the expected return, so we can assume that the standard deviation is smaller than security Y, and it is less risky than security Y, because security Y, with the same expected return, has a broader reach in terms of standard deviation. So the possible returns have a greater variation from the expected return than with security X. Now, those relationships can be examined in a simple question, so be aware of how security X, security Y stack up. And we've described that at the top of the page. Now, applying numbers, statistically, we're told there's a 68% probability with a normal distribution of a security yielding a return within 1 standard deviation either side of the mean, assuming that the returns, possible returns, are normally distributed. Well, we make that assumption to be able to apply this logic. And statistically, there's a 95% probability of a security yielding a return within 2 standard deviations either side of the mean. It's actually, to be exact, 1.96 standard deviations either side of the mean. But if they were to examine this, you can assume it's 2 standard deviations. So with that, we have a risk-return trade-off, and that is the level of additional risk an investor is prepared to take in the expectation of a higher return. So we're attracted to higher returns, but with higher returns often comes the chance of greater volatility, which means you could make a bigger loss than with a safer return. Standard deviation can help investors in this decision-making process, gives you the data. And generally, an investor requires extra compensation for taking on higher risk, and that's known as the risk premium. So we can look at the very basic question. The required return of an investor is the risk-free rate of return, which is usually linked to government securities, plus a risk premium. Now, how we calculate that risk premium, well, that's for later material. Paragraph 1.7, principles of portfolio theory. Now we go back in history, and it's relatively recent that the theories behind portfolio construction came about. And I'm just going to look at the points that are presented. Portfolio theory was developed by Harry Markowitz. Now, Harry Markowitz was an engineer, a chemical engineer, I believe, in the 1950s. It was a breakthrough in looking at risk with regard to portfolio of investments. Then, after the 1950s, William Sharpe came along and developed portfolio theory with the development of the capital asset pricing model, and that was in the 1960s. That in turn led to the development of arbitrage pricing theory in the 1970s. So this is the business schools in the US doing all this work. It was Roll, Rosenberg, and Ross. In terms of mainstream, we tend to focus on portfolio theory being the work of Harry Markowitz and the capital asset pricing model of William Sharpe. You're not going to be examined that, but that's very much the background. 1980s, PE to return on equity came forward from Gerard Wilcox. And Markowitz, in introducing the concept of expected risk, concluded higher expected risk should yield a higher expected return, which sort of intuitively we would accept, but he actually applied numbers. And the important development was the introduction of the concept of correlation. Now, correlation measures the way in which the returns of two or more different assets move in the same direction. So let's look at the points put forward, and then we'll reflect. We're told correlation is the relationship between the expected returns of two assets. Now, it can be more than two, but Markowitz did his work on two assets. And if you're examined on this, it will be two assets. The assets whose return move in the same direction are known to be positively correlated. And we give you an example there of an umbrella company and a raincoat company. More it rains, more both companies make a return. Assets whose returns move in opposite direction are known to be negatively correlated. An umbrella company and sunglasses company, the idea when one is making profits in the rain, the other is not. The correlation coefficient measures the relationship between the returns of those two assets and lies anywhere between -1 and +1. So there's the spectrum, and we're using the Greek letter rho to signify correlation, and it can be -1, where you have perfect negative correlation, all the way up to +1, where you have perfect positive correlation. If you have zero, that is where zero correlation, then the two assets have no relationship at all. Now, if we combine assets in a portfolio with less than perfect positive correlation, you will reduce overall portfolio risk. That's almost what Markowitz got his Nobel Prize for in economics. I mean, I'm simplifying it slightly, but that's the core issue, that if you bring two assets together that have less than perfect positive correlation, you'll reduce overall portfolio risk. So here's the formula for the calculation of standard deviation for a two-asset portfolio. Oh, do I need to know this formula for the exam? Sadly, yes. So if there's no way around it, you've got to memorize it. Memorize that formula, and then in the exam, the minute you get into the exam room, scrap piece of paper, when the exam starts, write down the formula. So what does it tell us? It's the weighting of the first asset, A squared, multiplied by the standard deviation of the first asset, A squared, plus the weighting, that would be 0.5, 0.6, whatever. If it was two assets and it's 0.5, it's going to be 0.5, 0.5, half each. So the weighting of the second asset, B squared multiplied by the standard deviation of the second asset B squared plus 2 multiplied by the weighting of the first asset multiplied by the weighting of the second asset multiplied by the correlation coefficient between the two assets, and that will be somewhere between -1 and +1. Then we multiply that by standard deviation of A multiplied by standard deviation of B. Now the last three terms, correlation and the two standard deviations, those three terms together are actually the covariance of the two assets. So please learn the formula, use the formula when you are practicing questions. It is highly likely you'll need to use it, albeit in one question.